All right, I think we're live. I'm going to just quick tweet out that we're live, and then we'll get started. So, yeah, I have something kind of exciting I want to do tonight. Usually, in these things, I just kind of work on sort of random stuff that's maybe easy to fit in, picking up pieces of things that I've already started. Today, I want to actually try to go through the whole process of making a new ship for my game. And so I don't have like necessarily any templates started or anything like that. I recently did this in one day for the first day of Spaceship Timber. And that kind of proved out that I have a lot of tools in place and things that make it more straightforward to do than it used to be. And I always want more ships for my game and for the different projects I'm working on. And I'll talk a little bit about what I'm trying to make today and why. But yeah, so we're going to try to make this freighter that's been converted into a battleship. I'm not going to probably spend a lot of time polishing the design, but I want to kind of go through the whole process of making it, and then some of the additional scripts and different pieces to fit it into the collection of assets that I have for my game. Maybe even get it in the game. I'm not sure we'll get that far, but kind of fit into the set of assets, get things like hard points and maybe weapons and shields on it, at least to start on that stuff. So it should be kind of fun to try to go through the whole process. And I think we should be able to do this in about an hour, hour and a half, 2 hours tops, if I can kind of focus and plow through and don't run into any issues. So it'll be an interesting challenge. Let me just tweet this out, and then we'll get started. So, let's see here. All right, and I'm gonna just quick test and make sure that the music is gonna work. I've had different issues sometimes with, there it goes, okay. I've started doing music, and I've had different issues with music working or not when I open, depending on what order I open OBS. So I just want to make sure that that's working. All right, yeah, so just a little bit of background about me and my project again. So I am an author of science fiction, and a lot of my project work is directed towards fleshing out this fictional universe that I have, that my books are set in. I'm developing a game that's set in this universe, and I'm kind of working towards building visual art capabilities, like being able to make trailers and sci-fi trailers and things like that that are set in this world. So what we're going to work on today is a low poly ship that could go in the game. But the way my design process works is I make these low poly designs, and then I kind of add extra detail to them to make high detail designs, and I like that because it kind of puts the focus on making interesting looking designs that work in that low poly space with recognizable shapes and things like that, rather than making a complex design and taking it back. I like blocking out a simple design and taking it to a more detailed spot. Can I click on this? No. Trying to see if I can. I don't know if OBS lets me bring up. It would be cool if OBS let me bring up comments. I don't know if it will, but I see you there, Katie. Thanks for stopping by and saying hi. So Katie's out of town right now, so I'm here by myself. So that's a good chance for me to do some streaming and work on my project. Yeah. So we're gonna be making this low poly ship, and what this ship is is something I've been kind of thinking about for a long time. So I'm going to bring up my world encyclopedia here. So this is my internal kind of personal wiki for my project, and I've got a lot of different things in here: my completed books, stories in progress, encyclopedia articles, stuff like that. And this ship is actually a ship that is mentioned in the book Uriel's Revenge. So some of this would be subject to revision because I've done a lot of actually making things concrete since I've written the books. But in Uriel's Revenge, at the asteroid, or not asteroid, but a moonlet called Titus's Tomb, they encounter this enemy ship. It belongs to the big evil corporation Russo International, and it looks like a freighter at first, but then they realize it's been converted to a battleship. So this is how it's described in Uriel's Revenge, as just some kind of freighter or carrier. I don't really describe what the ship looks like too much, but it's just loaded down with weapons. And I started thinking about this a couple months ago. What would this actually look like? I've been thinking a lot about ship designs, and I got this neat picture in my head of a freighter that kind of looked like a walkway and buildings that were perched on top of towers. So I try to think of my ship designs for the bigger ships as being very vertical, and I often kind of think of them as towers. And I thought, okay, well, if it's a carrier, then maybe you'd have these sort of multiple towers that are the freight that the carrier is carrying. But then the structure of the ship that the crew compartment would be in, and then this sort of surface that all of these guns could be mounted on would be kind of like a walkway or almost a rampart that ran across the towers of the freight of the ship. So I started sketching this a little bit. So in this drawing that I shared on Twitter a while back of Shima Station, which I've been working on a little bit, and I've streamed some work on, I sketched some of the different ship designs. Some just I kind of made up on the spot, and some I kind of had in my head. But the this sort of idea for this freighter is here. So it kind of looks like several cylindrical shapes with this like crew area and like connecting bit on the top, and then drives on the bottom. And then the other day, this isn't a drawing that I'm going to like complete or anything, but I think I was riding in the car, and while Katie was drawing it, I sketched out more of it, kind of a closer up view. So this is just the basic shape, but the idea is this this long part would be kind of like crew quarters and different spaces, maybe kind of engineering monitoring stations with windows. Probably won't be modeling the windows today for a low poly thing, but the point would be that you could sort of mount guns along these edges with hard points sticking out, so then the guns could face forward. With these ships, when you start trying to make them make sense, it's sometimes hard to figure out where to put guns so that they would have sort of like a good range of clear firing and stuff like that. So I thought that would work pretty well. And the story describes a enormous number of weapons, and rows of weapons. So they can kind of clearly see these. And so if you imagine this freighter kind of coming up, and later in the story it kind of comes up from behind this moonlet with the guns bearing on them, I think that would look really cool. So part of the reason I'm doing this is I need more ships for my game. I just want to have more to choose from. And then also someday I'm working towards the idea of making trailers, and I think it would be cool to make a trailer of one of these scenes from my game where the Martin Luther, which is the protagonist ship, has to face off against this ship. And I think that would be just a really, really compelling scene to make. So the start of making a high detail ship for that scene, we'll be making this low poly ship. We'll be making this low poly ship for the game. So yeah, so we're gonna get started here. Hello, Creates Bane. He's watching. He says always put the guns right where the enemy will come from. Yeah, that's right. The one interesting thing about my stories is that the drives are kind of magic. Like they don't. They're sort of cylindrical shapes, so you get that classical spaceship kind of like Star Warsy looking thing, but they don't like have rockets that shoot out the back. So I have a lot of ships that are sort of cylindrical and have drives in the back, and then have guns kind of sticking out the top and bottom, and they could like aim forward and back. This ship, because it's a conversion, doesn't necessarily have like a lot of places to stick guns down the top and bottom, or like the belly and back of it, but it will have guns on the front, and that's the front of the ship is definitely what would face the enemy for my ships, because the rear, even though there's not rockets, the rear is always going to be less shielded so that heat can dissipate, and for other reasons like that. So yeah, and then the way weapons and shields work for my ships too is that the weapons have special devices that sort of let them temporarily open holes in the shields that they can shoot out of. So even though the front of the ship is going to be the most heavily shielded, that's also where the guns will shoot from. So we'll try this. I'm going to get some music going here, and the first thing that we're going to do, once I get the music started, and I'm going to try to run the music a little louder than I did last time. I think it was a little bit too quiet. But yeah, the first thing that we're going to do is make a script that is going to hold the different functions that will make the ship. And then I'm going to try right away, probably like sooner rather than later, to kind of hook all these functions up to some of the other scripts that I have. Because one important thing that I want to do right away here, even though I'm going to parameterize everything, is I want to get this thing in roughly the right scale with some of the other ships that I have, and I want to be able to do that comparison while we're working. So let's get started here. And again, for people who are new for watching, I'm doing this work in Python. I have my own library that I wrote to do 3D modeling with. It uses some functions from the TriMesh library, which is very good, but a lot of stuff I've written myself, and I've written wrappers around TriMesh for things I don't like. And then I also have my own functions for like building scenes or hierarchies of 3D objects, and that's what we're going to be building the ship as for starters. It's just what's called a parts dict. So it's basically just a dictionary of 3D objects and then how they're relating to each other. I'm going to try to talk a little bit more tonight, since we're kind of going from beginning to end for how you do this, and kind of explain what I'm doing here. So I'm going to just close out some of this. I was working on the actual game earlier, but we're probably not going to get into that now, unless this goes really, really well and I run out of other things to talk about. I did some cool work on the game this weekend that I'm really proud of, but it doesn't look like a whole lot right now, so I don't want to spend too much time on that. Okay, so let's go in here. So all of my scripts for making the different ships are in here. I originally started putting a bunch of them in one file, and now I'm kind of putting them in separate files. So we're going to call this, we'll call this, we'll actually just call this battleship, for lack of a better word. I can always rename it later. I already have a ship that I call freighter, so we'll call it battleship. At one point I went through and kind of figured out what the right name for for the different ship classes was, and I can actually look that up while I'm going here, but we'll just call it battleship for now. So ship conversion. So we'll just make a doc string here, and I'm going to copy all of my imports from another. Actually, I'm not going to do that because I have a new sort of generic import. I don't think I need to do that. Let's see here. So, I think most of what I need is going to be in these two. And actually, I could import the types. So here's some definitions for commonly used types. Most of these are just really simple, like aliases for tuples and numpy arrays, things like that. There isn't really anything particularly special about them. And let's just grab these two just for the heck of it. For anyone who's watching, is the music at a good level compared to my voice? Could it be quieter? Could it be louder? How should it be set? Okay. So we'll just make a function here, battleship, and this will take a level of detail. And we won't really be using this level of detail too much right now, but we'll just build it in there. And this will return this hierarchy of parts that represents the ship. Okay, cool. Thanks for letting me know that the sound level is nice there, Katie. So this will be the low poly version of the battleship. Okay, so I think the first thing that I'm going to do is I'm just going to, oh no, the music, I think actually it just went onto New Song there, Great Spain. Is the music actually still not playing, or is it playing? It looks like it's playing to me. I think the first thing we're going to do is we're actually just going to make a very basic, just single mesh shape, and then I'm going to connect up some of this other stuff, and then we'll go back and finish modeling the battleship. So let's do that first. So we'll just, I'll just define, let me just take a look at how I did this here. So what I've been starting to do is like I parameterize everything. So I have all of these constants that represent the length and like big dimensions. Some of the smaller dimensions I kind of hard code. All the big important dimensions I will parameterize as constants. So here we go. Okay, so we'll call this, and we'll just use the prefix. I think this should be about, I think it should probably be about 200, actually maybe about 150 meters long. All of my units are in meters, so we'll start there. And so we'll just start there, and I'll return object. We'll just call core as a part, where our model is going to be just a cylinder that we'll define here. So we'll call our cylinder, oh, I need to import my primitives, that's not in U. So prim cylinder, and that'll be blen. We'll just give it a radius of like 40 meters and 8 subdivisions just for now. Okay, and then I'm gonna make a little thing in my workbench to test this, because that's what we're going to be testing with most of the time here. So I have this workbench script that I can kick different stuff off of. Yeah, so Free Narnian, this is White Bat Audio. He's a guy who does a lot of like cool electronic music and stuff, and he just makes it free for use for streaming. No royalties, no questions asked, just giving him credit. So it's kind of fun. I like to have something to listen to when I'm doing stuff like this. This a little bit bigger. So we've got to import our module here. Shit, I just imported this BS. And we'll call our function here. So battleship bs.battleship, and our level of detail by default is going to be 0, and then we're just going to look at the parts. So with parts, so now when we run this, it'll call this function that we built. We can take a look at that. Yep, so there's our cylinder. Really exciting. Okay, so now let's actually, I'm going to actually start getting this into the bigger context of the project. So just for what that looks like. So there's another script I can run here called Scenario Viewer, and this can load an arrangement of ships like from the game and load it into Blender. By default here, it's just loading this scenario that's just a bunch of ships laid out in a row. So here's basically all of the assets for the for the game that I have in here right now. And I want to be able to do a kind of a size comparison with what we're building now against some of these other ships. So I'm gonna try to get it in here first. And this is probably going to be the least interesting part, but I'm going to try to do it really fast. So what we're going to do is we're just going to copy. I'm going to make a new YAML, and we're going to copy this one. And let me just check my designations. I'm going to just give it a fake designation for now. So it'll be a XXF class, just until I come up with a better name. Actually, this isn't a battleship, it's gonna be a freighter. And we can just leave Turner Lewis as the manufacturer, because I think that's kind of the aesthetic that I'm going for. So Turner Lewis is kind of like an older manufacturer of ships in my universe, so they kind of have older, more outdated looking designs. They're nothing fancy or aesthetic, but that's fine. And for now, we're just gonna grab the whole thing. So this will just automatically load everything. I think I called it core. Yeah, core. So we'll just load everything. And we're not going to have any excludes. All of this data is not correct, but it doesn't hurt anything. For now, so we'll just leave it. And we can copy stuff in to this later. Let's check how I did this. Yeah. Okay, and XXX. So basically, this is kind of getting it ready to go getting it ready to go in the game, getting it ready to go in this lineup. So size, now I'm going to add it to the size comparison here. It's going to fit in the lineup, actually right in here. Jeez. I can type, I swear. Battleship. And then I just have to add it to my script here that will save parts out. So this script actually, when I run it, calls all of these functions to generate my different ship models and saves them to disk. And it runs really fast, which is kind of fun. I enjoy thinking about that. So we're gonna just add a little entry for this in here. So and we can clean up these imports later. Something to keep in mind when you're doing these projects, you know, to build momentum, you don't have to like go up to the top of the file to put in the import right away, right? You can just put it in where you see fit, and not worry too much about it. So let's see, and I called it, yeah, I did call it Battleship. So do stop Battleship 0, and then we just have to add this to this list of parts that we're going to save out down here. Parts. Okay, and then I just got to make sure in here, yeah, Battleship. So this is kind of like a name that's going to reference the files that we're going to save out here for it to load back in. So let's run this and see if we get anything. Okay, now if we go in models, we should see a Battleship folder here. It's got the egg file that's going to be used in the game. All of the parts that we're going to be looking at right now are going to be in this pickle file, this JSON file. That stuff is there. So I believe now if we run the scenario viewer, if we didn't see anything up, we should see that big cylinder sitting there alongside the other ships. Oh, okay. All right, there's another place that I forgot to add it. So we need to add it to the templates, our battleship.yaml. So this is just all of the data files where these descriptions of the ship for the game are gonna live. So I'm gonna add battleship.yaml here. And that should work. All of these data files are basically concatenated together into one big data structure that the game can assemble parts from. Yep, there it is. So there we can see, as we're working, a kind of a size comparison. And it's going to fit into the lineup automatically, and they're going to be spaced over and everything as we change the size of it. As you can see, there's a little bit of a border around it. So yeah, as we build this out, we can periodically rerun the jerk models script. Jerk, just so you know, is kind of like my code name for the game project. Jerk is the derivative of acceleration, so it's a physics term. That's why it's called jerk. But we can periodically rerun the jerk model script and then run the scenario viewer to see it in the lineup with the other ships. So Yeah, and I guessed about right. So I think I said this was, yeah, it was 150 meters. Here we can see kind of the size of things. So 150 meters is sort of about the size. So like this big freighter is quite a bit longer. Let's see here where I don't think there's like one core piece here, but like you can see this guy is like 320 meters long, this carrier. And this little ship here is actually not so little, is kind of my first rough approximation of what the hero ship from Uriel's Revenge, Martin Luther, looks like. So you're gonna imagine a big freighter type ship that's this length and quite a bit wider, kind of coming up against this small ship. Should be pretty intimidating. All right, so now we can go on and actually build the ship. Okay, so, and let me just rerun bench just to make sure everything's working there. Yeah, okay. All right, so how are we gonna start here? So we want this kind of set of 4 sort of rows of cylindrical tanks, and the idea here is these wouldn't have to be cylindrical either. You could swap them out like with you know, different shaped containers, or like racks of, you know, like shipping containers. I might try something like that. But then the width of this is gonna be run across by this sort of kind of rampart like structure that the weapons will come out of. And then I think in most of my drawings I've drawn 4 drives in the back. It's kind of hard to see in this picture, but there's gonna be some structures that kind of hold the things from the rear, and then there's also like the reactors would be back here too. So there's going to be like a bit of a structure for the reactors. So maybe what I'll do here for starters is, okay, I'll close some of this stuff out. So maybe we want to sort of identify the radius of and length of each of these like sub-containers, and then we can kind of scale the rest of the parts to fit that. So let's say, so we'll call that freight. So let's say the freight radius is something like, see if we want 4 across. We want the length of the thing to be 150. The width should be roughly 100 or a little bit more, maybe 120. So let's say the radius of each of those pieces is 12 or 15. So let's say the radius of a single chunk is 12, and then the length is, we want the length to be a bit longer than twice the radius. So maybe something like we could do 36. So actually we could just do like this, and then we can actually define like a spacing here too. So we could call it a gap. Type, I swear. Actually, do we want a gap? Yeah, I mean there should be a gap in between, maybe just like 1 meter gap. So the total width of the freight area is going to be something like 3 or 4 times the freight radius plus 3 times the gap, because there's 4, so there's going to be like, there's going to be 3 gaps in between. And actually we could do, yeah, we'll just start there. We can always tweak this, so I don't have to overthink it. So 3 times freight gap. And then this is going to give us the width, basically the width of that rampart that runs across the top too. So that would be, we'll just call that, let's see, we'll call that the spine. So the spine width, in this picture I have it extending a little bit beyond the edge of those freight tanks. But I think I don't want it going to the edge. I think I want it going to, I gotta get this music started. This music started here again. Let's see here. We'll start over with the synthwave stuff. I think I want it actually not going quite to the edge of the tanks. So the spine width, we'll say, is going to be the freight width minus, I don't know, the gap times 4 or something. Let's see, spine. And then we'll just get some other stuff in here too quick. Spine height, let's say that should be maybe, yeah, 12 meters. That seems reasonable. Actually, this is more like, we'll call this, what's the width of a ship? Is that the beam of the ship? Yeah, so we'll call this the beam. Actually, let's get these. We'll call it spine length. Actually, height is going to be a long Y, because that's how people would stand inside of it. I think it should be about as tall as it is wide, maybe actually a little taller. So we'll go 18. And then I'm just going to define a bridge area too. So we'll just call this part here the bridge, even though there's probably other stuff in there too. So the bridge, we'll call that, let's see here, we'll make that be, it's going to be about 4, and actually we'll just call this X. This will say will also be 18. Okay, this should give us enough to sketch out some of the basic shapes of the top of the ship, and then we'll go in and do the reactors and drives and stuff in the back. Okay, so okay, so let's start at the top with this, with the spine and bridge. Actually, this we can call this XC as well, because we're going to be using these together. And we're just gonna not worry about like chamfers and stuff now. We're just gonna get the general shape of this sketched out. So so we're going to start by making these outlines of things that we're going to sort of stack up these 2D outlines into 3D objects. That's kind of how the modeling process is generally going to work here. So we're going to start by making these 2D outlines of these shapes given these dimensions that we've defined here. So we'll start with the spine rib, and we've got to get some 2D primitives here. We're going to attach Y because our ship is going to be built kind of along Y, is the long dimension. This is kind of arbitrary for now. We'll get the right position here in just a second. And then we'll put the bridge on top here, which we have to make 2, but just as long as I'm thinking about it, we'll get it going here. And actually, just for ease, we can make the parent spine, and transformation will be half the spine height off. So all of these shapes that we're building are going to have the coordinate system center kind of at the center of the shape. So you'll see a lot of this sort of like half offset. The reason I'm doing that is because I want generally things to be roughly like where their center of mass would be, because like in the game we can have these ships like split apart when they get destroyed, and then the parts will move nicely if we do that. We could always make coordinate systems in different ways and then kind of fix things later, but it's just kind of a force of habit for right now. 2. And let's make our bridge. So the bridge is basically, it's going to look almost identical to this code for the spine, where we are basically making a polygon shape for the top, or the bottom, inset one for the top, and connecting them together to get this sort of like trapezoidal inset shape. And I think the only different thing that I'm going to do is I'm going to actually bevel the bridge rib right away, because I want it to have sort of corners, beveled corners on it. So I'll just gather these together. As soon as this works, we'll move these out. I think this is going to take a little tweaking to get these shapes to look like I'm kind of wanting them to. So, all right, let's take a look at what we have now. Whoops. Okay, yeah, so we got an invalid triangulation failing for the bridge. So my inset, my bevel needs to be bigger for the inset to work properly. Yeah, that makes sense. So actually, something that we can do. Yeah, I think I want to change it. We could also apply that inset separately, but I think I want the inset to actually shrink. Yeah, this doesn't look at all like we want. So this needs to be spine height 2 plus bridge height divided by 2. And then we also have to flip these around because our meshes were inside out. And spine height, yeah, there should be bridge height, and then it seemed like the bridge was too big, so oh yeah, this should not be 4 times freight rad, it should be 8, because there's 4 across, but the radius is double for each. So let's see how this looks. Oops. Yeah, okay. See, this is getting closer to what I was picturing. I think before I tweak this too much more, I want to see how the freight containers actually look underneath this, because actually I think we can make one change here, which is that this should be not 4 but like maybe 3, and the height, yeah, the height is right, and then I think this should be I think this is gonna actually look right. All right, let's try this. So here we go. So, and I'm gonna rename this to we want a length gap 2. We'll also make that 1 meter. Okay, so now we're going to make our freight containers and stack them underneath. And so there are going to be 4 across, and then the idea would be that there could be an arbitrary number long. I drew this picture with 3, but really how long it is just kind of depends. There's going to be other structure of the ship that kind of like would theoretically either go through the containers or like along the outside, so it can kind of be however long you'd want. But let's make those parts. So just call this the top. And then so we'll make a parts dictionary, and then we can just add them to it. So we'll say for and this is definitely something that's going to take a couple tries to get right here, but that's okay. And we can actually view these parts right away, separate from other things. And I've got a parts at parents, because we're going to parent these to the core. Okay, so just exit after this. So, so our part is going to be have the parent be core for now, and then the model is going to be a tank, which we will make here in just a second. We can vary this by, like having different models in just a second, but the trick here is going to be the transformation, which is just going to be a translation. But where is it going to go? So it's going to go let's see here. So I'm going to start over from the farthest one is going to be at going to be 3 times the radius plus 3 times the gap, or yeah, 3 times the gap divided by 2. So we'll just calculate it out here. 3 times freight rad plus, actually this is minus 3 times gap, and then we'll add on a offset of 2 times the radius plus the gap. Is that what we want? Because the first one will be over by 2 plus the offset. Yeah, that seems right. We'll be able to tell when we look at it whether it's right or not. So that's going to be all in X, and then our Y offset. So we'll just call this offset X. Our Y offset is going to be just for now, we'll make this easy in the y. I kind of I'm more concerned about x. So we'll do freight length plus freight gap times index. Oh, and this is gotta be column index here. And let's just make our tank model here. So the tank is just going to be a chase. It's just going to be a cylinder for now. That is the radius. Whoops, the length. It's the radius, and then I'm just going to define. So this is something that we would change based on the level of detail that we want. But for now, we'll just make the subdivisions be 12. Oops. Oh. Didn't add it. Okay, so all right, that's almost exactly what I was picturing, so that's a win. Let's get the y offset implemented correctly. So, and actually, let's calculate some of this stuff up front. So our total width would be we'll just call, let's see here, so x min. And offset y min is going to be a little bit different because I want to leave room for gaps on either side. And actually, we'll add in some pieces here to fill those in, so we don't have actual gaps. But it's going to be something similar. So let's just make the number of rows a variable here, so that'll be like the number of rows, so we can experiment. So let's see, the total y is going to be the number of rows times the length plus the number of rows minus, let's see, it's actually going to be the number of rows plus 1 times the length gap. So then the offset is going to be that divided by 2. And this will be the center of the first tank. So it's going to be that divided by 2. Plus half of the length gap. No, the whole length gap. Plus half of the length. And then from there, it'll be, yeah. And let's add something here called let's add this like spacers in there too. So this is like the actual tanks. And then we'll do the skin for the spacers. This is going to be arrows. So there's going to be n rows plus 1 row of spacers, and this is going to be roughly the same thing. For sure it's going to be the same thing for X, but for Y it's going to be offset Y min plus this amount, and then minus half the gap. And make a spacer model here. Is also going to be a cylinder, and it's going to be gap, and we'll do like a quarter of the radius, and we'll do, just to make things simple, we'll do just 4 subdivisions, so it's like, it'll be like a square shape. Or maybe we'll do 6, so it's like a hexagon shape. All right, let's take a look at this. I'm sure there's something not quite right in here. Yeah. Yep, so we're off by a half. It looks like we're off by a half of the length somewhere. Oh yeah, because, yeah, freight length divided by 2, so this is going to be I don't know if this is right. Yeah. That looks actually, oh yeah, we're still off by a half. And let me just actually, we're gonna look at this in Blender just to make sure that it looks right before I go on. So I'm really proud of this functionality. So this lets me look at a set of parts. Actually, so we'll just say freight. This lets me view a set of parts in Blender, and this is just a really nice way to like interactively like be able to manipulate things, look at things, and make sure that things are what you expect. Yeah, so we don't have any overlaps here. Everything is lined up. We've got our... Oh, that's interesting. Let's see, is that just the shading, or are we not... Oh, we're not aligned in the center here in X. What's going on there? That's funny. I wonder if that's like an integer division thing. Because this should be a half. This gap here in the middle should be distributed between the two. Maybe I just forgot to divide by 2 somewhere. Let's see here. Y offset min. Oh yeah. So this should be divided by. Oh yeah. This is supposed to be 1.5 times the gap there. Yeah, there we go. So now we've got that gap split between the 2 sides. We've got our spacers, and let's see, the coordinates of these end parts should be kind of symmetrical in Y. 37 meters, negative 37, 55.5, yeah, okay. So all that looks good. Okay. So now, I think the way I'm going to do this is I'm just going to kind of tack the other parts on the ends of this, kind of keeping the center of mass of the whole ship in the center of this arrangement. So we'll see how that goes. This is a little bit of a mess. Let's see here. Yeah, this is actually... call this max, and we'll say set y min, and that's, we got to add back these on. So half of the, but then actually the whole gap. No, just half the gap. Okay, now this will become the starting point for our spine. Now, so instead of spine, we'll call this freight y-max. So and we will concatenate we want to look at things. And we can concatenate our freight parts here. And we should get something that looks pretty nice. Yeah, there we go. Okay, so we need to offset our spine by half its height. That's funny. Oh. Spine, yeah, plus spine height divided by 2. Yeah. Okay. So, let's take a look at this. A couple things that I'm thinking about right now. This spine is way too wide, too tall. I'm gonna actually load this into Blender with a little person for reference. And then we can kind of fiddle with the size a little bit. Because I think that's too tall. But before we do that, why don't we 12 meters. Yeah, 12 meters is high. Because the story is more like 3 or 4. So it should actually be more like, oh yeah, 18 meters. Jeez. Be more like 8. Yeah, that looks more correct. And then I want to get to the point where we're adding some hard points here too. But let's add sort of the rear. Yeah, let's add the rear section. Let's see if we can get that sketched out pretty quick. So, I don't want to just reuse the spine. I want to have a little bit different part for the rear. In my drawing, I had this sort of structure behind here. Let's see if I can do kind of a simple approximation of that. So that's going to be a structure that is roughly 2, 3, 3, 4, 5, 6. 6 times the radius plus you could say 3 or 4 times the gap, and in width should be something like maybe 1.5 times the radius. And XZ. And let's actually make a variable for the thickness of this thing. Rear thick. That should maybe be like not super thick, maybe 4 meters. And we'll give this a bevel 2. Chord. And we'll just give it that same amount. Bevel is the thickness. And rib. So we can do thick. Okay, and then can just add that in here. Four. Jeez. 0. Max. 2. And then let's build the just build the rear reactors and drives here in one go. So I like to use, and actually we'll just call this we're gonna make a set of parts here. So we can just look at this section separately and as we build. So let's just take a look at what that's. Yeah, this kind of looks like what I expected. Really need to fix this guy. That shouldn't. I've been trying to fix my stuff so that it produces points that are in the consistently like a counterclockwise order, so that when you start putting these different functions together, you end up with shapes that you don't have to reverse the faces on. Okay. And actually, before I go on, just want to make sure that this is the right size in relation to everything else. Then we'll get the radiators and drives in there and we'll be done. Or not the... not the radiators. I mean, that'll be part of it too, but... yeah, this is could increase the width of that a little bit, but this is basically looking like what I was expecting. Okay, so let's make a little engineering section. We'll make it sort of a squashed hexagon shape. So and I'm not going to bother naming the ribs different this time. We're just gonna build everything all at once here. So circle. And we're gonna get ready to put some drives in here too. So just as long as I'm thinking about these offsets here. So let's see here. I've got to think about how I want to do this. I I think I was initially thinking about drives directly behind the cargo. I think that's how, yeah, that's kind of how it looked in most of the pictures. But I'm wondering, I'm kind of thinking about stuff like this a little bit more lately, and I'm kind of wondering if they should be offset to kind of be clear of the freight area a bit. And that would also give me an excuse to make a nice wide reactor section. I could even actually stack the drives on top of the reactor section on either side. We could see how that looks. But let's just get started with something simple here. So we've got to arrange the drives kind of like we did with the cargo. So so I think there's going to be 4, and the radius is going to be something not too big, something like 4 meters. And let's just get them across first. So this is going to be kind of similar to what we did with the thing, but this is a little bit easier because there's not going to be a gap. So they're just going to be mushed right up next to each other. So steps 2 times 2 plus and then set plus equals times 2 times index drives of drive. And we might make a second row here in just a second. Drive, which we don't have yet. Parent equals drives and the translation of like 3 0 offset 0, and our model is just going to also be a cylinder. Cylinder of and subs, and yeah, let's just start with this and see what it looks like. Oops. Oh, okay. So this I've gotta keep subtracting here. Maybe this thing is the problem. Let's see here. I'm curious what's going on here. I thought I had worked this out so that stuff wouldn't come out inside out. Maybe not. We'll make this 8-sided. Too thick. Oh, that's weird. Yeah, this is... That's not the problem. I don't want to edit this right now because it's going to potentially screw up some other stuff, but this needs to be fixed so that it doesn't produce these half inside out meshes. For now, we can just reverse this. Okay. Okay. Come on. Whew. Yeah, for starters, and then why did these not end up at the right offset? Oh. That's why. Still not right. Okay. And we need to do jeez. Okay. Yeah, so first of all, these need to be bigger. And then second of all, I think yeah. This is starting to look like what I want. We're almost there. So, okay, so this is kind of like my original design here, but oh, nice. Thanks for stopping by, Freenonian. Yeah, thanks a lot. Thanks a lot for watching. Really means a lot. I think kind of my current design approach, I wouldn't, for ships, I wouldn't have these directly in the rear. Do I care about that? I'm trying to think. I need to make some decisions, some better decisions about how my ships work. Let me think about this. No, I have designs where the drives are just completely behind other parts of the ships. I think yeah, I think this is okay. And this definitely is like along the lines of the design that I've been picturing. So the only missing thing here is going to be a couple of radiators. Actually, let's make that reactor a little longer. Again, think about this. Yeah, this is looking really nice. It's fun. It's fun even when it's kind of a simple blockout to start looking at it in 3D and thinking about the stuff. You really start to be able to picture it. I'm gonna think where I would have radiators on this. They could, I think, oh yeah, so like in this picture, I have them kind of coming out the sides at the ends. So let's do that. Let's add a couple of radiators in. And then it's getting kind of late, and we've been going here for a good, hour and a half. So we'll kind of take a look at this in the lineup and call it good. So, okay. Yeah, so let's add in those radiators. So, okay, so we're gonna say react width equals this. The nice thing about this approach, right, is, you know, some of these questions about how components are arranged or things, you know, you don't lose all of your work when you start moving things around. Like all the stuff that I have for kind of making the high detail versions of the ships is robust to how things are placed. So if I decide, nope, I want to have those, I want to have 2 rows of drives, one on either side, kind of above the freight, that'll work fine too. And actually, I was thinking about, you know, being able to have additional rows of freight. So in that case, there isn't a good place to fit drives where they're sort of exposed. So I think this is fine. The drives in my world are kind of magic. They operate by kind of interacting with a magical parallel worlds where they can kind of function like propellers. So it doesn't really matter whether they have space in front of them or behind them necessarily, depending on how they're constructed. So and let's see here. Let's call this Z is going to be well, let's see. Our Z is going to be probably something like 18, and Z is going to be react length like 0.8 of the length of the reactor, and the thickness is going to be something like 1/4 of a meter. So I'm just really struggling to type tonight. I think I need to get more sleep or have less caffeine in me or something. Okay. Let's see now. This is going to make something that has its thickness in Y. So we want to rotate these around the X axis. By 90 degrees. Oh, hey, Patrick. Yeah, we're having a good night. Katie is out of town, so I'm hanging out here by myself trying to get some work on my project done and making some pretty good progress here, so that's good. I started a new ship from scratch. I don't usually do that on these streams, and it's going pretty well, so. So now we're gonna have 2 of these, and we'll just make them directly. I can't be bothered to write a loop right now. It's getting too late. So, and we're gonna call them A and B. So, so the parent's gonna be the reactor, which I'm just calling react. And radiator, and so we'll do the right hand side one first. This time we're going to use a full transformation. You'll see why in just a second. Oh, nice. Sounds like Patrick's doing something more useful. Oh, and I'm not an anarchist, Patrick. I know I'm friends with the anarchist Bible study people, but be the radical they think you are. Yeah. Nope. Sorry. But yeah. It's a good way to spend evening, doing something creative and productive. So. He's editing Christian videos for Muslim countries for a missionary. Nice. I've never done video editing, so I don't know what that really involves. I'm going to have a vague picture of it in my head, but so we're going to just make things easier here. We're going to go react width divided by 2 minus plus rad xz0 2 minus offset. So we're gonna stick them in like, yeah, less typing. Yeah, that makes sense. And this we can actually calculate outside here. Oh, I don't have an identity. That's funny. Y 180, and then these also go here. Let's take a look. Oh, they ended up inside. I tried. Let's see where I went wrong. So yeah, so Patrick asks whether I listen to death metal while coding, like in Silicon Valley, or Final Fantasy One-Winged Angel on repeat. So I have a couple of different playlists that I listen to. One of them, it's not death metal, but it is mostly like metal. I'm not like a fan of death metal, so it's more kind of like progressive rock, new metal, kind of more poppy metal type stuff. Breaking Benjamin I've been really into for like the past year. So stuff like that. I also have another playlist that is basically just really stupid pop music, and that is nice for just not having to think too hard and for like going fast. Let's see here. Plus 2 plus xz divided by 2 minus rad offset. Where did I go wrong here? I feel like this is right. Times 2 plus radiator xz. We gotta look at this. So rad offset. Really got something screwed up with my one function there that's bothering me. That's gonna have to be something I fix after this. Oh, yeah. Okay. X is the long dimension. Y is this? No? Yeah. Yeah, as long as you can type some Diary of Jane lyrics, just as long as we don't get a copyright strike. I really, really wish that you know, because like YouTube lets, like, they have agreements where, you know, you can use different music in the background for a lot of things. I would really love nothing more than to just put on the music that I listen to on these streams, but I'm sure that would not be good. And I'm just a tiny little channel, and I don't want to get my channel struck or anything like that while I'm starting out, so I'm not gonna risk it. Yeah, what the heck is going on here? So X is the long dimension, as it should be. Oh, do I need to, let's see here, react with plus radiator. Plus radiator. You know what? I think I've gotta bring this into Blender to look at it. I'm not gonna get any farther with this by looking at it and scratching my head. Okay, so let's just take a look at this here. 26 meters. So yeah, the X dimension of this is 66. So 66.5 divided by 2. 5 divided by 2 plus 18 divided by 2. This one, yeah, this should be 41.25. Yeah, see, that's where I want it. What is going on here? Oh, I bet I know what I did. I did react len. No? React with. What the heck? Radiator X. React with. Divided by 2. All right, time for some debug printouts. And then we're gonna call it good for tonight. Crate Spain, thank you so much for hanging out. It's really fun doing this when I know that people are watching. It helps me stay focused and motivated, and I hope this is interesting in some way to people or inspiring. So thanks so much for hanging out. And I'll be sharing pictures on Twitter of progress or picking this up later. So thanks so much for coming. Okay. Yeah, what is going on here? Oh, react width is, that's what's going on. Yeah, react width ends up being the radius of the circle. So So really, I want this times 2 divided by 2 here, and then that should give me what I expect. Yeah, 72. There we go. Okay. Where's my exit that I added here? All right, let's see if this gives us what we want. Yeah, that looks more like it. Oh, now we're off by 1 on the outside. Minus red offset. What is going on? I'm struggling tonight, guys. I think it's time for me to hit the sack here too. So, oh, I know what's going on here too. Yeah, yeah, because I rotated. Yeah, so I'm constructing this thing with a certain radius, and then I'm rotating it so that the vertical planes are on the side. So that means it's actually narrower. So what we actually want to do, instead of using react width here, we want to actually just find the width of react. So react width actual. So we're going to do a P2P on react 0 and take the 0th element of that. Actual divided by 2, and index into scalar. Oh yeah, P2P on axis 0. Yeah, there we go. Okay, so stuff notwithstanding, you know, some silly issues with our radiator. This is, you know, getting pretty close to what I was picturing. Obviously, we want some more details like hard points for a lot of guns along this part. I'm definitely going to be playing around with the size and shape of this bridge area if I can get a person in there for scale. But let's just, I'm going to fix that reactor quick, and then we'll get it into, or not reactor, the radiator, and then we'll get it into the lineup and just take a look how it looks size-wise next to the other ships. Maybe we'll do a little code cleanup at the end, just for my own sanity, and then we'll call it a night. Okay, so let's see what's going on. Yeah, see, this function, I think, is not right. Need to write some tests, because generally these functions should make solids without flipped faces if you give them ribs that are counterclockwise. I believe that's the convention that I've established. That's better. Okay, so let's get rid of our debug stuff here. Let's clean up some imports. Oh, nice. Was that the only import that we had below? Oh, yeah. Cool. And let's fix this import word here. Better. And this. this up. And let's grab the rest of these constants and bring them up to the top. Yeah, I'm pretty happy with how this looks. This is really, really close to what I've been picturing. Okay. And let's run our script to generate all of the models. And then run our scenario viewer, and then we'll be done. Yep, there it is. And there's a few different things that I would do here. Probably increase the number of subdivisions. There's definitely more detail that we could add, especially for the bigger ships. I want to add a little bit more detail, even though they're sort of low poly, because the sort of level of detail should be preserved at the same scale, like between the small ships and the larger ones. But overall, I think it's kind of the right size, and you know, it could be bigger by stacking more containers on. And probably something that I'll be doing too is adding like additional maybe like beam-like structures that run down the length of it. That's something that I had in this drawing, sort of like a lengthwise spine. So that's probably the next thing. But I mean, we got a really good start on this, and I'm happy that it's not just a set of parts, but it actually is here in the lineup, kind of for comparison and experimentation. So real soon I'll have this in the game. I'll be able to start experimenting with it there. That's all a good start. So maybe not quite as far as I wanted to get tonight, but good progress on something that's kind of tricky to. It's always tricky to start and do one of these. It's easy to mess around with you know, designs that you've already started making and make little tweaks and little adjustments, but it's hard to start something new. All right, well, thanks for watching. For everyone who came and watched, I'm gonna call it a night tonight, and I'll probably be streaming again sometime soon. It's been fun to do this, or get back into doing this again. So